So welcome to my demo of Split. Split is a Google Photos-like service that automatically tags your photos so you can query them without having to manually tag your photos. So I'm just going to show you a quick live demo because that's the easiest way to get knowing, understand what it is. So I've already uploaded all my Instagram photos onto here just before the demo, so we wouldn't have to sit here while it works. And as you can see, there's a lot of photos on here. And if I want to find all my photos when I'm doing one thing, it's really tedious, and I have to go out and select each one. So that was why I wanted to do this project. So let's say I just want to find all my running photos. So all I have to do is type run into this query bar. It takes a couple seconds to load, and now it's going to show me all my photos where I'm running. This can be done for anything bike. I have a lot of running and biking photos just because that's what I spend my time doing. But it doesn't only work for that. I want to find all my photos of food. It has all those. So I don't know what's going on here. I was a little confused because there's a bunch of stuff in a shopping cart here, but it usually works. So that's basically how it works. So just on a high level, I have give it a second. I have a web server that's in EC2, and it's just built off a PHP backend. So when the user drags in a photo to that drag and drop box, what happens is the PHP backend takes it, it compresses it, and it uploads it to an S3 bucket. And when a new image is uploaded, this triggers a Lambda function. And the Lambda function takes the image, calls the Amazon recognition engine on it, which is what is used to which is the computer vision algorithm that is used to tag the photos. And then it takes those tags and it stores the photo's path, also photo's key name, with its tags in a database. And then when you go to query your photos, it again goes to the PHP function. This PHP function goes to this same database, finds the keys of all the photos that have this tag, and loads them in from the S3 bucket and then displays them to the web page. So basically what it is, I use EC2 because an XAMPP web server is hosted on an EC2 instance. And as I said before, when the user uploads a photo, it's put into S3. When the user queries a photo, it's pulled from S3. And this is scalable because if I needed a higher web server with more throughput, then I would just have to put it in a bigger EC2 instance. This is the same thing with S3. It's where the photos are stored. It's scalable. If I needed more photo storage, I would just put it in a bigger bucket. For Lambda functions, this is what was triggered every time there was a new upload, and it happens once and only once for every upload. So it doesn't happen every time you query your photos, because that's all stored in the database. It is scalable because you could just make more Lambda functions every time, but it is a little inefficient because every time you upload a photo, it makes a new Lambda function, which has to make a new connection to the database. So if I really wanted to make it efficient, I wouldn't have used Lambda, but I did in this case because it allowed me to learn how to use Lambda and use triggers such as a file that's uploaded to S3. For a relational database service, I just store all the tags in a MySQL RDS instance, and it's very scalable because it's a MySQL server. It also doesn't take up much space at all because all it has is paths, and all it has is the photo's key name in the S3 bucket, its tags, and those confidence intervals. So it's very small for every photo. It's just like maybe a few lines of text. And recognition is Amazon's computer vision algorithm that does the actual tagging of images. It's scalable because all it has to it's just called once when the Lambda function is called when every image is uploaded. So it's just a one-time thing. So we could just call more recognition functions with more images. So the last thing about one of the most challenging parts here is I originally wanted this to work with multiple users, which is something I'm going to work on in the future. But unfortunately, getting the Amazon Cognito engine to work and having you log in with Cognito and having it take that unique ID for every photo and store it in a special place for every photo, and then in the database store who owns what photo. Just ended up being out of the scope for this project. Just being it ended up being a little too much. So for this current project, at this stage, it doesn't support that. It's more just a proof of concept. But in the future, when I do have time, I do want to get Cognito working. So this could really, anyone could really use this service, which would be really my goal.